In today's lesson, we're going to be talking more with line angle relationships. Okay, so I have a diagram right here where we have two parallel lines, M and N. Okay, and that's what it says up here. These are two parallel lines, two lines that never intersect. Whenever you have two lines that intersect that are cut by a transversal, so L in this case is my transversal. Okay, it's a line that cuts through two parallel lines. They form angles within the diagram. So we need to recognize the name of these different types of angles and angle relationships. So let's look at, first I want to define the different parts of the diagram. The interior is everything on the inside of the transversal, or I'm sorry, the two parallel lines. Okay, everything inside the two parallel lines cut by the transversal. The exterior is everything on the outside. So all of this is considered the exterior. You can think of it like as a house: interior of a house, inside, exterior, outside. Okay. Now, certain interior and exterior angles have different relationships. And actually, there's other types of angles we've talked about before. For example, let me erase this. Let's see if this works. It's going fairly quick. There we go. All right. Now, we know about vertical angles. Remember vertical angles? Those are angles on the opposite sides of two intersecting lines, right? Vertical angles. 3 and 2 are considered a vertical angle. 5 and 8, they're considered vertical angles. They're on opposite sides of two intersecting lines. And what do we know about vertical angles? They are congruent. Okay. So we already know that type of relationship. Another type of relationship between the angles is called alternate interior angles. Alternate interior angles are angles, remember when I define my interior and exterior, okay, it's key to know where the transversal is. Alternate means it's on opposite sides of this transversal. Opposite sides of this transversal, that's what alternate means. Interior means that they're on the inside of the lines. So they're on opposite sides of the transversal and on the interior. For example, angle 3 and angle 6. Angle 3 is on the left side of the transversal. Angle 6 is on the right side. So they're alternate and they're both on the interior. Okay. Another pair of alternate interior angles is angle 4 and angle 5. Left side, right side on the interior. Alternate interior angles are congruent, meaning they are the same measure. And you can tell, look at the 4 and 5 are both obtuse angles, so they're going to be the same measure. Now, alternate exterior, remember here, alternate meaning on opposite sides of the transversal. Okay, so remember here's my transversal. Okay, alternate exterior, that means it's going to be on opposite sides of the transversal. Now the exterior, remember here's my exterior, all this area. All right, so the two angles that are in the alternate exterior is angle 1, which is on the left, and angle 8, which is on the right. Okay, alternate, left and right, and in the exterior. Alternate exterior angles are also congruent. All right, here's another pair, angle 2 and angle 7. All right, opposite sides of the transversal and in the exterior. So we have alternate interior, alternate exterior. Another pair, which is not mentioned above, but I want to mention it, is called same side interior. So same side meaning that they are both on the same side of the transversal and on the interior. So same side interior angles, angle 4 and angle 6. Now look at angle 4. It's on the right. Angle 6 is on the right of the transversal. Angle 4 is an obtuse angle. Angle 6 is an acute angle. So that relationship is, they're not congruent. They're not the same measure, but they add up to 180 degrees. They form a straight line. All right. Another same side interior is 3 and 5. Right? Both on the left side of the interior of the transversal, excuse me, and on the interior, so they are also supplementary. The last part I want to call is the corresponding. Corresponding, to help me see where the corresponding angles are, what I do is I draw a circle around the two intersecting points of the transversal. So the corresponding angles are the angles that are in the same location of each circle. For example, 5 is in the top left and 1 is in the top left of this circle. Though they are both in the same location of those circles, and they're both obtuse, meaning they're both going to be congruent. Okay, number 2 is in the top right. Number 6 is in the top right. Those are corresponding angles. They are congruent. Number 8 is on the bottom right. Number 4 is in the bottom right of the circle. They are congruent and the corresponding. And the last one, number 7 and number 3, those angles are in the bottom left of the circle. They are corresponding. They are congruent. So it's important to know these names and their relationships. And if you also take a look, if you notice, all the acute angles are going to be the same measure, and all the obtuse angles are going to be the same measure. So all I need to know is one angle. Okay, one single angle. Let's figure out what it is. Okay, so I'm going to say my angle 2 is 20 degrees. All right, I'm just making that number up. We know angle 3 is going to be 20 degrees because it is vertical. We know angle 6 is going to be the same thing as angle 2 because it is corresponding. So that's going to be also 20 degrees. We know angle 7 is going to be congruent with angle 2 because it's alternate exteriors. That's also 20. And also these are vertical, right? They're vertical to each other, so both of these are 20 degrees. Now the other angles, they're obtuse angles. They're going to form a straight line with the acute angles. So the obtuse angle is 180 minus 20, which is 160. Okay. And I can use the other one. This 4 is vertical to that, so that's going to be also 160. Number 8 is 160 degrees. Also, it is an alternate exterior with angle 1. And angle 5 is also 160 degrees because they are corresponding. So like I said before, all the obtuse angles are going to be the same measure. All the acute angles are going to be the same measure as long as you have two parallel lines cut by a transversal. And it's important to recognize the names. You recognize the interior, okay, and the exterior, and be able to recognize those relationships. All right. So that's it for today's video. We're going to be looking at a couple diagrams and solving for the angle measures of those diagrams. If you have questions in class, let me know.